All right. Today we are going to talk about the geological time and the geological time scale. When we started this course, I said the Earth is known to be 4.6 billion years ago. So something which is 4.6 billion years ago, it means there are geological processes that have been taking place over a very long time period. So now the Earth geological time scale is divided based on changing character of life form through time. The character of life form through time. So it's designed based on what happened and then what happened next. Now, we know, for example, how the human time scale works. We have, for example, days, we have hours, you have minutes, you have seconds, but then we can also have weeks, months, years, we can also have decades, centuries, millenniums, and the likes. So now, that character change of life is, for example, trying to understand when did first organisms with shells get introduced on Earth? When did fish get introduced on Earth? When did first land plants get introduced on Earth? When did amphibians and reptiles get introduced on Earth? When did mammals uh, get developed on Earth? When did the humans start walking on Earth? So all those are events that took place at different times, and therefore they can be used to divide the geological calendar into different time scales. So now, if we look at the geological calendar, we see that it's divided into, for example, what we call an eon, an era, and a period. So it's an epoch. Now, what you get to see is that those classes are not different from our human classes that we use. For example, having year, decade, century, millennium. So it would now mean, for example, an eon is equivalent to a millennium, not in terms of time, just in terms of comparison. An era is equivalent to a century, a period is equivalent to a decade, an epoch, on the other hand, is comparable to a year. They are not equivalent, they are basically comparable because they cover different time scales. Now, a millennium can be subdivided into centuries. A century can be subdivided into several decades. A decade can be subdivided into several years. The same applies here. Now, for example, we have an eon, which we can subdivide into several eras. Then we have one era, which we can subdivide into several periods. Then we have one period, quaternary as an example, which we can subdivide into several epochs, right? So all those are designed based on uh, changes of character on the Earth's surface. Now, the current epoch in which we are is called the Holocene, right? However, they are thinking of introducing a new uh, epoch called the Anthropocene, which would be the period under which the Earth has been vastly changed by human activities, like never seen before. So that qualifies to be an epoch on its own because it's the only time period when the Earth is heavily affected by human activities. So that's very important. Now, so it basically means since 4.5 billion years ago, the Earth has been changing, right? Uh, the Earth has been changing. New organisms have been introduced, so and so up to such a time that we have humans here. There are some organisms that existed at one point in time, but they are no longer found. So it's the same. It basically means the evolution would not end here, but would continue, right? So it means possibly the time for humans would also come to an end, and something else, something much more intelligent would be introduced, much more intelligent than humans. So just watch Mother Nature and see what uh, uh, nature is capable to do. So now, how do we know some of those? Much of the evidence still exists to this day because a lot of such organisms left fossils. They left bones preserved within sedimentary rocks. Right? This is a typical example of a fossil, an animal bone, an animal that once existed but then later disappeared from the Earth's surface, right? Later on, it disappeared from the Earth's surface, but we can excavate its remains and be able to understand how big this animal was, as an example. Here is another example of uh, basically fossils that belong to an animal that once lived. Uh, Now, the same is true for this, whereby basically a paleontologist is hard at work trying to excavate this animal fossil to be able to study what kind of an animal once lived. So that is part of the reason why I said sedimentary rocks are so important because uh, the past the evidence about past environmental conditions are still buried beneath there, and we can excavate those to be able to understand what has been taking place on our Earth surface. So this conclude our discussions on this unit. We would then thereafter continue with the next unit, which talks about other stuffs. So thank you very